All right, let's jump right into a question that's so fundamental you probably never even stop to think about it. How did we, as a species, all agree on where here actually is?
I mean, think about it. We pull out our phones and bam, there's a little dot that tells us exactly where we are. But that simple dot on a map, it's the finish line of a race that took centuries to run, a quest to solve one of the hardest problems we've ever faced, creating one single system to find any spot on Earth.
So here's the first big hurdle. If I tell you something is 100 meters to my left, that's great, until I turn around. Now its position relative to me has completely changed. My here is always moving. For a map to work for everyone, everywhere, we need a single, rock-solid origin point, a universal point zero.
And so the great search for here began. The most logical place to start? Well, you gotta think big. Really, really big. Okay, how about we go all the way back? I mean, all the way back. The Big Bang itself. What could possibly be a more absolute, universal origin point than the very beginning of everything? Seems perfect, right?
Well, there's a small problem of scale. The universe has been expanding for a while, and now we're about 10 to the power of 26 meters away from where it all started. That's a number so huge it's basically useless for trying to find the nearest pizza place.
But here's the real deal breaker. Even if we could handle that mind-boggling distance, we don't actually know which direction to point in. So, for practical navigation, the Big Bang is a total non-starter. Rejected.
Okay, fine. The start of the universe is out. Let's zoom in a little bit. How about the center of our own galaxy, the Milky Way? At least we know where that is.
And when I say we know where it is, I mean our aim is just staggering. This quote says it all. We can pinpoint the direction to the galactic center with a precision that's like standing here on Earth and being able to tell two pebbles apart on the surface of the moon. Absolutely incredible.
But, and you knew there was a but coming, even with that unbelievable accuracy in its direction, the distance to the center of the galaxy is still gigantic and not known precisely enough to be a useful starting point for navigating around town. So another one bites the dust. Rejected.
All right, forget deep space. Let's bring it way, way closer to home. The center of our own solar system, the sun. It's right there. We see it every single day. This has to be the one.
And nope. Think about it from our point of view, standing on a spinning planet. The sun is a moving target. It rises, it moves across the sky, it sets. It's the exact opposite of the fixed, stable reference point we're so desperately looking for.
So after searching the entire cosmos, from the beginning of time to the center of the galaxy to our own sun, we realized the answer wasn't out there. We had to, quite literally, come down to Earth. The solution was right here all along.
And this led us to the first half of our coordinate system, latitude. This is what tells you how far north or south you are. And it turns out nature did give us a fixed point for this one.
And that magical fixed point is the North Star, Polaris. Because it just happens to sit almost perfectly above the Earth's axis of rotation, it's the one star in the night sky that doesn't seem to move. So if you can find Polaris, all you have to do is measure the angle between it and the horizon. That angle is your latitude. It's such an elegant, beautiful solution to finding your north-south position.
Okay, so north-south. We've cracked it. But this just brings us to an even tougher nut to crack, defining east and west. This was famously known as the longitude problem.
Just try to wrap your head around this for a second. If you're standing at the geographical North Pole, any direction you point is south. There's no natural east or west. It's a concept that simply doesn't exist there. It's something we had to invent completely on our own.
And that's the absolute key. Unlike latitude, which is tied to a real physical object in the sky, longitude had to be based on something else entirely, a human agreement. We all just had to get together and decide where to draw the starting line.
And the line we all eventually agreed on is the Prime Meridian, which runs through the Royal Observatory in Greenwich, England. There's no special physical reason for it to be there. It's the zero line just because we all decided it would be.
But, agreeing on a line is one thing. Actually figuring out how far away you are from it, especially when you're bobbing around in the middle of the ocean, that's a whole different ballgame. The solution, when it finally came, was pure genius. And it didn't involve looking at the stars. It involved looking at a clock.
So this is the big aha moment. To find your latitude, your north-south position, you need a fixed point in space, the North Star. But to find your longitude, your east-west position, you need a fixed point in time, the time back at the prime meridian.
Now, for centuries, this was just a cool idea, because making it work required a piece of technology that didn't exist, a clock that was so accurate and so tough it could keep perfect time for months on end, even while being tossed around on a ship at sea. The invention of that clock, the marine chronometer, changed the world.
So here's how it works. You have this super accurate clock on your ship, and it's always set to Greenwich time. Then you just have to figure out when it's local noon, the exact moment the sun is highest in the sky where you are. At that instant, you look at your Greenwich clock. The difference in time tells you your longitude because we know the Earth spins at a steady 15 degrees per hour. Simple, brilliant, and it finally made it possible to map the entire planet.
So, by combining a fixed star and a fixed time, we wove a grid across the surface of the Earth, a truly amazing achievement. But both of these incredible methods rely on one thing, being able to see the sky. So that leaves us with a final question. What happens when it's cloudy? Or when you're just lost inside a building?